All right, what's up, virtual learning AP statistics students? This is going to be your video for quarter 4, week 1. Our topic is writing hypotheses for significance tests. All right, so I'm just going to run you through the slides. I'll do this each week so that you are ready for this week's problem set and materials. All right. Agenda, so there won't be an Ignite today, so you don't have anything to do in Schoology for your Ignite. We're going to mainly be working on these two, writing hypotheses for a significance test. I'll kind of set it up for you first, and then we'll do a couple practice problems. And then I'll let you know what you should be doing for your asynchronous work for the week. All right, so let me give you a little bit of information. So right before spring break, we started talking about a significance test. We haven't done a full significance test yet. I'm going to present that next week. But this week, I just wanted to do a short lesson on how you write hypotheses for a significance test. So I'll just read through this first slide here. So a significance test is a formal procedure for using observed data to decide between two competing claims. Those two competing claims are often called hypotheses. So the significance test is our second inference procedure. Our first inference procedure was the confidence interval, and our second one, again, is the significance test. Sometimes these are also referred to as hypothesis tests, so you might see it both ways. So usually at the beginning of a significance test, you always write your hypotheses, but there are several requirements for you in order to write good hypotheses. If we kind of go through these requirements, requirement 1 is the hypotheses always need to come in pairs. So there are always two hypotheses. The first one is what we call a null hypothesis. It's abbreviated as H with a subscript of 0. And the second one is called the alternative hypothesis, and that's abbreviated with the H and a subscript of A. So the null hypothesis is always a claim that we weigh evidence against. So what you're basically going to be doing is assuming the null hypothesis is true, and then you're going to be using collected or sample data, and you're really trying to disprove that null hypothesis, because basically you want to support your alternative hypothesis, and the alternative hypothesis is the claim that we're trying to find evidence for. And again, I'll get into this a lot more next week, but right now we're just concentrating on how do we write hypotheses. So the second requirement is that each hypothesis should start with the same parameter. So usually our two main parameters we're going to be using for these hypothesis tests are either P or mu. So remember, P is your population proportion and mu is your population mean. The third requirement is that the null parameter should be followed by an equal sign, and then i.e. P equals 0.75. So again, usually what you're doing again is writing your hypotheses in pairs. So again, we have a null and an alternative. Usually we put a little colon after it. And your null hypothesis, you start with your parameter. So again, P, I could have also put a mu there if I were trying to test a mean. So let's just assume I'm testing a proportion. This parameter always needs to start with or it always needs to have an equal sign and then some number that you're trying to weigh evidence against. Then the third, and I'm sorry, this should say A here, the alternative hypothesis parameter should be followed by one of three things. So either a greater than symbol, a less than symbol, or a not equal to symbol. So the example I used for the alternative is P is less than 0.75. And then that fifth requirement is that the values in each hypothesis must be the same. So notice that I made both of these two values the same. Those numbers have to be the same. You have to use the same parameter. Your null has to be an equal sign, and then your alternative can be either a less than, a greater than, or a not equal to. And we'll kind of see how to write these as we go through a couple examples here. But those are the 5 requirements that you need in order to write a pair of hypotheses. All right, so let's do a couple examples. So let's write the appropriate hypotheses for each of the following scenarios. All right, so I have 3 scenarios here. I'll go through, I'll read through it. I'll give you a minute here to try it on your own, and then I'll go through how you actually write the hypotheses. So number 1 says, a certain university has decided to introduce the use of plus and minus with letter grades, right? So like A minus, B minus. Some universities just have grades A, B, C, D, F with no plus or minus signs. So they'll do that as long as there is evidence that more than 60% of the faculty favor the change. So in a random sample of faculty will be selected, and the resulting data will be used to test the relevant hypotheses. Let P represent the true proportion of all faculty that favor a change to plus-minus grading. All right, so if you want to take a sec here to pause the video and try to write your hypotheses, please do so. All right, so I'll go through the answer. So when I am writing hypotheses, I always start with a null and an alternative hypotheses. Notice we're told that to use P. We're talking about a proportion here. We're talking about the proportion of faculty that favor this change. So both of these hypotheses are going to start with a P, my population proportion. Remember what I said is that your null hypothesis always has to be an equal sign. And then your alternative is either going to be a greater than, a less than, or a not equal to. So I'm going to start with the, so I'll come back to that in a sec. So my null is I am going to assume that 60% of faculty support the change. And what I'm trying to show is that more than 60% of faculty favor the change. So what I have to do is I have to set my null hypothesis to 0.6. P equals 0.6, and then my alternative, the one that I'm trying to gather evidence for, is that I want to show that the proportion is greater than 0.6. So again, my null, P equals 0.6, my alternative, P is greater than 0.6. All right, so hopefully you got that one right. We'll move to our second one. Number 2. Researchers have postulated that because of differences in diet, Japanese children have a lower mean blood cholesterol level than U.S. children do. Suppose that the mean level for U.S. children is known to be 170. Let mu represent the true mean blood cholesterol level for Japanese children. Okay, so again, what we're going to do is write our hypotheses in pairs. So we have a null and an alternative. And now this one, we're actually doing it for a mean. So we're going to be gathering evidence for a mean. So I'm going to use the Greek letter the Greek letter mu, which represents a population mean. All right, so I am again trying to show that Japanese children have a lower mean blood cholesterol level than U.S. children do. And it tells us that the mean level for U.S. children is known to be 170. So that's what is going to be my null hypothesis, is that mu is equal to 170. That's what I'm going to assume to be true for Japanese children. But really what I'm trying to show is that Japanese children have a lower mean blood cholesterol level than U.S. children. So my alternative is that mu is going to be 170. So I'm going to assume that the mean is 170 for the Japanese children, but I'm really trying to gather evidence that it's actually lower than that value. So that would be my pair of hypotheses for number 2. All right, number 3, last one. A county commissioner must vote on a resolution that would commit substantial resources to the construction of a sewer in an outlying residential area. Her fiscal decisions have been criticized in the past, so she decides to take a survey of constituents to find out whether they favor spending money for a sewer system. She will vote to appropriate funds only if she can be fairly certain that a majority of the people in her district favor the measure. Okay, so what we're doing here is, again, writing hypotheses. So I'm going to have a null and an alternative. In this case, what I'm looking for is I'm trying to show that a majority of people in her district favor the measure. So we have to know what that word majority means. Majority in this context will represent 50%, or sorry, more than 50%, right? So greater than 50%. So in this case, we're looking at a proportion. So I'm going to go back to using P for my parameter. This is going to be the true proportion of people in the district that favor the measure. So my alternative, I'll actually do this one first. I want this proportion to be greater than 0.5. So I'm trying to show that that alternative is true. So then in order for this to work out, I have to set my null hypothesis to be equal to 0.5. So I'm gonna assume that it's just a 50-50 split, but I'm then gonna try to gather evidence that actually more people favor the measure than they don't. So that is the third set of hypotheses. Which one that I didn't do is a not equal to. So I'll just kind of briefly show you this one. So basically, if I were to use a not equal to as my alternative hypothesis, if I had evidence for that alternative hypothesis, basically that would just mean that it's not a 50-50 split, that more than 50% either favor it or they don't, right? So it's a little more ambiguous, but a not equal to, so you're not going to be concluding that one's necessarily bigger than the other. We're just showing that it's not equal to 0.5. All right, so that'll give you kind of a little bit on if it's a not equal to. So I'll change that back to greater than. Okay, so that's basically what you're going to be doing in this problem set. Is you're going to be writing hypotheses. You're also going to be looking at a few hypotheses that have already been written and kind of evaluating them. So that brings us to the textbook homework. So this is in Schoology. So page 595, we're doing problems 1 through 8. Just because we have a shortened class period this week, there's not a whole lot of material on this assignment, but I did want you to get working on a little bit of this significance test work. So you have this week to work on the problem set, and it is going to be due at 10 a.m. on either your Monday or prior to either your Monday or Tuesday week 2 synchronous class date. So if you're in periods 2 or 3, it'll be due at 10 a.m. on next Monday. If you're in period 6, it will be due by 10 a.m. on Tuesday. All right, and then the tutorial videos, these actually I assigned all of these prior to spring break. So if you haven't had a chance to view those, I think it will be helpful to prepare for what we're going to be doing next week. If you watch those, if you've already watched these videos, that's great. But if you haven't had a chance, this would be your best bet. Okay, so I hope that made sense. If you do need help, please send me an email, or I am going to be available for office hours. This week it'll be on Wednesday and Thursday from 8:30 to 3:30. Sorry, 8:30 to 9:30 a.m. If that doesn't work for you, just send me an email and we can maybe set something up on Google Meet for Friday. Okay, that's it. Thanks for watching, and have a great day.